Dear viewers, welcome to this series of design concept videos. In this series, we are seeing tools that are used in design methodologies of Lean Six Sigma like DMA/DV or in the improve phase of a DMAC project. As part of this series, in this video, we will understand about Pugh Matrix. Let's get into the video. As I was explaining, Pugh Matrix is a design tool, and basically the tool is to identify an appropriate solution from the available list of solutions. Pugh Matrix is a criteria based decision matrix which uses certain criteria scoring to determine which of these several potential solutions or alternative solutions should be selected to replace the current design. The technique gets its name from Stuart Pugh and has become a standard part of Six Sigma methodology if you want to shortlist a solution during the design phase of your DMA/DV project or improve phase of your DMAC project. So for us to implement Pugh Matrix, I have created a template. Let's get into the template and understand about this particular tool. As you see here, this is an example of a Pugh Matrix used in an industry where we are making a electrical or an electronic equipment to achieve a particular outcome. So since this is electrical or electronic equipment manufacturing, so the criteria on which I want to evaluate my new design are followed: cost of components, ease of reproducibility, ease of aligning to the standards, ease of aligning components, ease of soldering, ease of overall assembly on the bench, ease of pressure testing, ease of overall assembly in the field, ease of helium leak checking, ease of preparation of CICC, ease of manufacturing of individual components, efficacy of transfer of current with low loss, efficacy of transfer of helium to next length, ease of providing required electrical insulation, ease of providing required electrical isolation to ground, ease of mounting instrumentation. Now, as I told, this is an industry of electrical or electronic components or device manufacturing. So these are all the criteria on which I want to evaluate my design. But if you want to evaluate a design in some other industry, for example, if I want to evaluate a mobile application, I'm a finance or insurance company. Let's say I'm a finance company where I'm dealing with mutual fund. If I have a mutual fund and I want a mobile application form which will be used by my users, and I currently have one version and I am planning to replace it with a new design, then what will be my selection criteria or what will be my criteria? Definitely, when I'm talking about mobile application, the user interface, the storage capacity, the speed at which the application reacts to requests, the security features of or the data security of the mobile application. All these are different criteria on which a mobile application will be evaluated against a current model. So depending upon the industry in which you are operating, depending upon the industry where you are planning to implement your Pugh Matrix, your criteria changes. And once you fill this first column of criteria, the second column, rating, is basically how do you want to rate your criteria. Not all these criteria will have the same amount of importance in your final design. So some of this will have high importance, some of them will have low importance. So depending upon the importance, you can give a rating anywhere between 1 to 10. In this case, for example, cost of components, efficacy of transfer of current, ease of providing required isolation from ground. These are all things I have given a rating of 10. Why? They are very important. Whereas overall assembly in the bench, providing required electrical insulations, these are things where I have given 1 because in this particular product these are things which are not so important. So anywhere between 1 to 10 you can give a rating, and for you to give this rating you can have a discussion with your cross-functional team members, and each one of them will bring lot of required necessary inputs when you fill this column. And when there is a difference of opinion among the cross-functional team members, you can use the technique of multi-voting and understand how majority of the cross-functional team members think about a particular rating to a particular criteria. And once we have done this, the next thing that we need to do is, this is my current design. So this current design is what I am currently using. If you do not have a current design, then you can take the benchmark value as your current design, and against that benchmark value you can score your potential designs from which you need to choose your solution. In this case, I have 5 potential design: design 1, design 2, design 3, design 4, design 5. These are the 5 potential designs from which I need to choose one, which will then replace my current design. And how do I start scoring? I start scoring values -1, +1 and yes. When do I score -1? If I think my new design is performing poorer compared to my current design on this particular criteria, I will score a -1 here. If I think my new design is at par with my baseline in this particular criteria, I'll score a yes, and yes here stands for same. -1 stands for one level below, and +1 stands for one level better. So if I think in ease of aligning components, my new design scores better than my baseline design, and then I put a +1 here. So -1 for poorer performance, yes for similar performance, and +1 for a better performance. So considering these scorings, I fill this for all the designs which are under discussion, from which I need to choose my final solution that will replace my current design. As I score this, the most important section is finally where you come to the summary. So in summary, I have basically 4 rows. The final row is very important, but before that we will understand about the other rows. So this row, I have created a formula, sum if the entire range if it is +1. So that means I am going to add all the +1s, and similarly here I am going to add all the -1s, and here it will be the net result of how many +1 I have and how many -1 I have. Here I have 5 +1, here I have 4 -1, and the net result is +1. That means on one parameter the new design is performing better than the old design net, right? But these scores are not that important. What is more important is your final weighted value for improvement. Now what is this final weighted value for improvement? This final weighted value for improvement is a sum product of your rating and design scores. What do I mean by sum product of rating and design scores? Let's see this. So my rating value here is 10 and my design score is -1. So the sum product will make it 10 into -1, which is -10. 7 into yes, no value because it is at par, so it is -10. Then you have a -9, so it become -19. You have a +4, so -19 plus 4 will become -15. Another +5, so -15 plus 5 will make it -10. So then you have yes, -10 plus 1 -9, -10 plus 3 -6, -6 plus 2 -4, but again you have a -10, so -4 and -10 will make it -12, and then you have a -14, and then you have a -8, which will make it -22. So this is nothing but the sum product of these rating and this design. And as you do a sum product, the -22 is a very, very low score. So the design 1 cannot be a replacement design for the current design. So similarly, I do the sum product formula here for all my designs. So design 2 scores a +3, design 3 scores a +10, and design 4 scores a +3, and design 5 scores a +22. And how do I got +22? Because many of the criteria where there is a high score, design 5 is doing better than my baseline design. So here also it does better than my baseline design. Here also it does better than my baseline design 10. So here at 9 it does better than my baseline design. So considering all these high rating values where design 5 is doing better than the baseline design, we end up with a score of +22. So now we can easily choose design 5 as the best of the solution among the available solution to replace my current design. So friends, this template where I have given the formulas for each of this column, if you think this template will be useful for you to use a Pugh matrix in your project, Feel free to write to our email address. I have given the email address in the description of this video. So you can write to us. We'll be able to share this template. We are more than happy to do that, so that this template will be useful for you to do a similar kind of a few metrics in your project and find a solution which can replace the current design with the criteria based scoring. I hope this video was useful for you to understand what is Pugh Matrix, its role in solution shortlisting. For more videos on design tools, Lean Six Sigma, concepts, tools and techniques in Minitab, and general quality management videos, please subscribe to our channel. Thanks for your time. Thanks for watching this video. See you in another video.